Picking up from the last tutorial on the Comp3D, we'll look at a couple more advanced tools within that effect. So firstly, I'm just going to set myself up with a black background and my sky shot. And a comp as normal. And I'm just going to add into this a wipe pattern. Okay, so what I've got here ends with this wipe pattern. All wipes naturally have a transition in them, so I'm just going to delete the grade just to get a set of 4 boxes just for this demo. So double clicking the Comp3D. So as we would expect from the last tutorial, because I've given 2 inputs with only 1 layer manipulator, the wipe has gone over the sky and that's being keyed over the black, so this is our response. So what we saw in the last tutorial is this is the background by default, and then layer 1 and then layer 2. However, there's one deviation from that, and that is if I open up the layer and enable displacement mapping. What a displacement map does is it takes the luminance values of a second input and uses them to push in Z the position of the matching pixels in the accompanying layer. So when we have displacement map on, this is the background, this is layer 1, and this is the bump map for layer 1, so it isn't layer 2. So we can already see what the bump map is doing. We can see that where we have white pixels, our image plane on layer 1 is being pushed forwards. And there are a number of controls that we can use to modify this effect. And they are generally spread between attributes, and under deform there's a displacement map here. So we have a displacement amplitude. The more we push this, the bigger the effect. And you can see that the white areas are coming forward and the black areas are going backwards. The reason for that is the 0 is set to 50%. In other words, anything that's 50% grey in here would have no effect. So if I set this to 0, we can now see that actually the black parts stay put. The other control we have here is a blur in the bump map. It's usually necessary to have some level of blur just to avoid aliasing, but effectively what it's doing is a defocus on this bump map layer before it gets bump mapped, and visually that has the effect of rounding off the shape that's being created. The other important control here is the subdivision. By default it's on 3. It basically controls the resolution of the bump map. The higher it goes, the more accurate the bump map, but the slower Mistika will run. It goes up to 7, and you'll find your system will run quite a bit slower on 7. Perhaps a good demonstration of bump mapping would be to try and create some 3D text. Now, Mistika doesn't have a 3D text function as such. We can sort of do a poor man's version of it using these bump maps. So we'll go through the process, not necessarily to prove that Mistika can or cannot do 3D text, but rather just to show the controls in action for bump mapping. So to set it up, I'll just go back, and in fact, just go back to a default comp. And so the first thing I'm going to want is something to be bumped. So let's just give ourselves a red plane, and we also need the bump map. So we'll create a title, so as we can see, the bump map is, the text bump map is completely obliterating the red because we've yet to tell it that that second input is in fact a bump map rather than a extra layer. So we'll turn it on. You can see that our output's gone black. The reason for that is by default a solid has 0 alpha. So if you're ever using solid as a foreground in a comp effect, obviously it needs its alpha channel, otherwise it stays invisible. So now we can begin to see something that perhaps we can make into 3D text. And the first obvious problem is that it's bumping out of this flat bit of red, not cutting out of the red. So what we also need is an alpha channel in the shape of the text in order to ensure that only the pushed part of the red is seen. So how we can do that is if I take a copy of the title, I'm going to hit G for group. So now my red plane is inside that group. I'll go inside the group and I'm just going to add the title. I'm going to connect it like this. And then under the parameters for title, I'm going to make sure that it applies to the mask channel. So now my red video actually carries that alpha channel. So now we can start to see something interesting happening with the text. It's being pushed out. There's something 3D there, but it's not really what I'd call 3D text. So the first thing that we can fix is the resolution. We can see that the bumping, the forcing out, isn't really relating that much to the actual shape of the letters, and that will partially be because the subdivisions are so low. So as we click this up, we'll be able to see that the shape becomes a little bit more true to the text, but also we can see how curved it is. Well, the curve will be because under the displacement map, by default, we've actually got quite a lot of blur on it. If I drop it down to 0, you can now start to see something that's beginning to look a little bit more realistic as some 3D text. In fact, a little bit of blur is always good because it'll slightly round off the edges and they'll catch the light a little better. Now if we look into these sides, we can see some strange stuff going on. The reason for this is that, in fact, we're using exactly the same image to do the bump map as we're using to cut out the bump map. So that means this very pixel that's being pushed outwards to create an edge is also the very pixel that's being cut off. So what we need to do is to make the alpha channel slightly bigger than the bump map so that it is cutting off beyond the edge of the bump. So simply we can do that. Again, just pop that back into our group, and I'm just going to add from the keying menus grow. And remember, we can get into our grouped parameters in here. So if I ramp up grow, obviously if I go too much, what we'll see is we're starting to reveal more and more of the back plate, if you like, that it's bumped out of. So what we want to do with this is just tune it to the point where it's getting all of our edge but nothing of the back plane. So in essence what we've got here is a bump map and an alpha channel all working together. And with this is a good layout to play with the lights. So at the moment we have the one default light, and if we open the light folders we can see there's an X, Y and Z position of where the light is, where it's pointing, what colour is it, and then various other attributes such as its intensity, light type and so on. In addition there's also ambient light. So this is the default level of light that anything in our 3D space will inherit if it's not actually under any light at all. That's why we can see these edges. Even though the light's directional coming from the front, we can see these edges because there's a little bit of light energy floating around, as it were. If I were to put these down to 0, we can see that we now can't see those edges because they don't have any light on them. Let's put a little bit of light on them maybe. So there are three types of light in Mistika. there's directional, point and spot. Directional is effectively a wall of light where every beam is travelling in exactly the same direction. It probably mimics direct light from the sun most accurately. So as we can see, if I move this, it's not making any difference at all. The reason being is that the angle of the light, it doesn't matter where this is, with a directional light, it's the angle that's relevant. So if I go to the target and instead move its target around so that it's changing the angle of the light on the geometry, now we can see a bigger difference happening. So let's change to a different type of light. If we go to a point light, with a point light, all beams of light are coming from this particular point. So each of these bits of geometry will be receiving light from a slightly different angle. So that way when we move this one around, we see a different response. The third type of light is a spotlight, which as you can see is giving a limited area of light, along with the ability to be moved and angled as you see fit. The size and decay of the spotlight can also be changed. We can add multiple lights into the scene. Where we had add folder, there's also add light. So now I have two lights. So let's change the second one, for example, to be a point light. And let's move it to somewhere interesting. Remember, we can use the views from here. So if I view the top, I can see my cameras here, my spotlight's going here. So for example, I might want to move this over to be above it, try and pick up some shines to fill the edges a little bit. You'll remember the specular and gloss attributes here. Now that we've got some lights, they'll make more sense. So I can increase these to change how shiny the surfaces are, and therefore how they'll react to the light. So for example, dropping the gloss down and the specular up, we can start to get some shines appearing on the edges. So the bump map or displacement map function works by taking a second input to any layer and its brightest points being used to offset the Z position of a given pixel. The displacement map works alongside any of the other distortion functions as well. For example, this would bend the whole thing around also. So although the 3D environment stops short of being a full modeling package, there are still a fair few things that can be accomplished with bump maps when we're using Mistika to create visual effects.